Good evening, sir.
Yeah, good evening, Ajay.
Good night. Good night. Aku bisa terus baca.
Yeah. Shall we start, Ajay?
Yes, sir.
Yeah. Now, in the last class, I think I explained the concept of the simple microscope. In the case
Yes,
of a simple microscope, you're going to place the object between the principal focus and the optic center, where you are going to get a magnified erect image, isn't it?
Yes.
In the case of a compound microscope, we are going to use two lenses. This O is called as an objective lens and this E is called as an eyepiece. So what is O stands for?
so objective.
Yeah, it is an objective lens.
Yes, sir.
O stands for.
So objective lens.
Yeah, it is an objective lens and it is of lesser focal length. E represents the eyepiece. This is of larger focal length compared to objective lens. So is the objective lens, E is the eyepiece. Eyepiece is having higher focal length compared to the objective lens. In the case of the compound microscope, the object is going to be placed more than the focal length. Somewhere here there will be a principal focus. Beyond this principal focus, we are going to place the object. U0 represents the object distance. U0 represents the object distance. For this object AB, the image will be A dash B dash. The image will be A dash B dash. In front of this A dash B dash, to place a one more lens, which you call it as an eyepiece. You have to place this eyepiece in such a way that this position A dash B dash should occupy a distance less than the focal length of the eyepiece. Less than the focal length of the eyepiece. That means object is placed, A dash B dash is placed between the principal focus of the eyepiece. This is the principal focus of the eyepiece and this is the optic center I'm talking. So whatever the image is formed by the objective lens, that is A dash B dash, is an object for the eyepiece now. A dash B dash will act as the object for the eyepiece now. But that object is placed between the principal focus of the eyepiece and the optic center. So for A dash B dash, you are going to get a enlarged erect image. So this final image is erect of object A dash B dash. But with respect to AB, this final image is inverted, no?
Yes, sir.
So whatever the final image we got, that is A double dash, B double dash, this is inverted and highly magnified. So the image which is magnified, virtual and inverted, this is the image formed by the compound microscope. This is the nature of the image which is obtained by the compound microscope. And please remember the magnification formula for the compound microscope. Ajay, you have to remember this formula. There is a lot of
Yes, sir.
different formulas here. The very first case is the magnification formula when the image is formed at the least distance. Excuse me. In the second case, image is going to be formed when it is at infinity. In the second case, we are studying the magnifying power formula when the image is formed at infinity.
Infinity, sir.
Yeah. Look at this. We have a different terms here. V naught divided by U naught into 1 plus D by Fe. 1 plus D divided by Fe. What is V naught and what is U naught? V naught is the image distance for the objective lens. U naught is the object distance for.
So objective.
Objective lens. What is Fe represents?
So focal length of eyepiece.
Focal length of the eyepiece. Actually, this is the standard formula you have to remember. From this, we have derived the other forms. So please remember the standard result first. Minus V naught by U naught into 1 plus D divided by Fe. D represents the least distance of distant vision. You know that it is 25 centimeter for normal human eye. Fe is the focal length of the eyepiece. V naught is the image distance of the objective lens. U naught is the object distance of the objective lens. And you know the lens formula, right?
Yes, sir.
What is the lens formula? 1 by F is equal to 1 by
1 by
V
V
minus
minus
1 by
U.
U. Now on simplification for this, we can substitute for objective lens. Now you can substitute for V naught or U naught. You are going to get these two different forms. You will get these two different forms. I know it is very tough to remember all the three different forms. So usually what we will do, we will remember the standard result and the lens formula. Now, if they have given the focal length and the object distance, on simplifying this equation to get V naught, after getting V naught, we are substituting here. If you remember these two other forms, you can directly simplify that. So this is the formula when the object is placed at the least distance. The second distance, what is the second magnifying power? This is the formula when the image is formed at.
Say infinity.
When the image is formed at infinity, the magnifying power is given by the formula minus V naught by U naught. This term will be as it is. Instead of 1 plus D by Fe, I am going to get only D by Fe. Only the D by Fe. What is the comparison between simple microscope and compound microscope? Look at this. In compound microscope, we are getting 1 plus d by f. We are getting the same thing in compound microscope also, 1 plus d by fe. Additional term is this, minus v naught by u naught. Just compare so that it is easy for you to remember. So for simple microscope, it is just 1 plus d by f. For compound microscope, it is 1 plus d by fe. For this, you have to just multiply minus v naught by u naught. Minus v naught by u naught. This is the formulas when the image is formed at least distance. If the image is formed at infinity, just you have to eliminate that 1. Any doubt, Ajay?
No, sir.
Okay. One more important parameter you have to remember here. That is the length of the tube. The length of the tube. Length of the tube. What is the length of the tube? Look at this term. What is V naught and UE? V naught is the image distance of the object lens. UE is the object distance of the eyepiece. Look at the diagram. Look at the diagram here. V naught is plus UE. V naught plus UE. That is nothing but the distance between two lenses, no?
Yes, sir.
This distance between the objective lens and the eyepiece is called as the length of the tube.
Yes,
so
sir.
what is the length of the tube?
Sir, distance between the objective and the eyepiece, sir.
Yeah, that is L is equal to V naught plus UE.
Yes, sir. Sir, that's the image distance for objective plus object distance for eyepiece.
Yeah, very good, correct. Image distance of the objective lens plus object distance of the eyepiece. So if you substitute the value of UE and V naught in terms of focal length and object, you can remember this formula. So on substituting for V naught, you will get this. On substituting for UE, you will get this. But no need to remember this too. Just you remember this. On simplification by substituting the lens formula, you can get all these things. So if the image is formed at infinity, then the length of the tube will be V naught as it is. Objective of the eyepiece is nothing but Fe there. So V naught plus Fe will be the length of the tube if the image is formed at infinity. If the image is formed at infinity, object should be placed at principal focus, no? To
Yes,
get the image at infinity, where should the object be placed?
So focus.
Principal focus. So to get the image, you make this object distance of the eyepiece as focal length of the eyepiece. So this implies that the object is placed at the principal focus of the eyepiece. So the image will be formed at infinity. At that time, you will get the length of the tube as V naught plus Fe. Any doubt related to compound microscope?
Understood, sir.
Yeah, thank you. Good. Let us go ahead. That is telescope. You know that telescope is going to be used to see the distant object. Telescope is used to see what?
Distant objects, sir.
Distant object. In the telescope also we are using the two lenses. One is called as the objective lens, the another one is called the eyepiece. But look at the difference. Focal length of the objective lens is more compared to the focal length of the eyepiece in the telescope. Focal length of the object lens should be more than the focal length of the eyepiece in telescope. But this is ulta, no, in the compound microscope.
Yes, sir.
In the compound microscope, focal length of the eyepiece is more than the focal length of the object lens.
Yes, sir.
Yeah. So where you have to place the object? Actually, this object is placed where? AB is the object actually. This object is at infinity. Because telescope is used to see that very distant object. So object distance should be very, very, very large. It must be almost at infinity. So whenever the object is placed at infinity, the final image is going to be formed at PQ. This is the final image. For the objective lens, this is the image. For the objective lens AB, image will be A dash B dash. When this A dash B dash acts as an object for this eyepiece, image is going to be formed, which is an inverted ear, but it is an enlarged. But if the object is placed at very infinity, you can look very, very, very small image compared to the object because the object is placed at infinity. So you're getting a final image which is virtual, which is inverted and small in size. Inverted, virtual, and the small image is going to be formed. Yeah. Now, can you tell me what is the length of the tube here? Comparatively, in the compound microscope, what is the length I've told? Image distance of the object lens plus what? Object distance of the eyepiece, right?
Yes, sir.
Yeah. Now, in the case of a telescope, where is the object placed? In the telescope, where is the object is placed?
The object is placed at infinity.
Yeah. When the object is placed at infinity, where the image will be formed?
So focus.
Yeah, principal focus. So image distance of the objective lens should be equal to focal length of the objective lens, no? Because object is placed at infinity. Image should be formed at the principal focus. Then image distance should be equal to principal focus, no? I mean, focal length of the objective lens, no?
Yes, sir.
So instead of V naught, shall I write it as F naught?
Yes, sir.
So F naught plus UE will be the length of the tube in the telescope. In the case of what?
Telescope.
Telescope. So please remember, in the compound microscope, whatever V naught you are getting, you have to just replace that by what?
So F naught.
F naught. Okay. Yeah. So this is the formula for the length of the tube in the case of telescope. And please remember, what is the magnification formula for telescope? It is minus F naught by Fe into 1 plus Fe by D. Ulta. 1 plus Fe by DE. Look at for compound microscope. it is D by FE, no? For telescope, it is FE by
Sir,
FE by D.
D, sir.
Yeah. So just remember one formulas, you can derive all those things when you are deriving. And one more formula you can also remember, which can be done in solving the numericals. Magnifying power for compound microscope or for telescope, you can also tell the magnification of the objective lens into the magnification of the eyepiece. Magnifying power is equal to magnification of objective lens into magnification of eyepiece. Actually, whatever F0 by Fe you are getting, that is the magnification for eyepiece, objective lens. 1 plus Fe by D, whatever you are getting, that should be for magnifying of eyepiece. So, the product of magnification of objective lens into the magnification of the eyepiece, the product is called the magnification of the telescope. Yes.
Yes, sir.
So this is the concept of the telescope. So let me solve the problems based on this.
Yes, sir.
Yeah. Take up the very first problem. I've done the calculations part also. What type of instrument it is? What type of optical
Some
instrument it
microscope,
is?
compound microscope.
Yeah, compound microscope. What are the focal length of the two lenses? One is 1.5.
So one is 1.5, other one is 6.25.
In compound microscope, you know that the focal length of eyepiece is more, right?
Yes, sir.
So 6.25 centimeters should be the focal length of what? Eyepiece. So 1.5 centimeters should be the focal length of what? Objective lens, right?
So objective lens.
Now, object is placed at where?
Sir, 2 centimeter.
From which lens?
Objective.
So this is the object distance of the objective lens. So it is U not, right?
Yes, sir.
Okay. Then what is where the final image is formed?
So 25 centimeter from my lens.
Yeah, that is the least distance of distant vision. You can take it as capital D, that is 25 centimeter. They're asking you to find what distance between?
So 2 lenses, L, sir.
Yeah. You know the distance between the two lenses is nothing but image distance of the objective lens
V
plus
naught plus
object
UV,
distance
sir.
of the eyepiece, right?
Yes, sir.
Correct? No?
Yes, sir.
Yeah. What is the image distance formula for the lens? By using lens formula, can you replace for V naught? Object distance into focal length divided by object distance minus focal length. This is for objective lens. Plus, if you use it for eyepiece, it should be Fe into capital D divided by Fe plus D. Remember this. So this is the formula to find the length of the tube. What is the formula to find the length of the tube? U naught F naught divided by U naught minus F naught plus Fe into D divided by Fe plus D. This is what I've given in compound microscope. Look at this. In compound microscope, what is the length of the tube? U naught F naught divided by U naught minus F naught plus Fe D divided by what? Fe plus D.
Fe by D, sir.
Yeah, this is the length of the tube. So that formula we are using here. Yeah, can you simplify and tell me the value for this? Substitute U naught F naught, U naught minus F naught, Fe D and Fe plus D values. You substitute these values and tell me what you are going to get for the length of the tube. This is equal to, what is U naught? 2.
Sir,
F naught is 1.5
1.5, sir.
divided by 2 minus 1.5 plus focal length of eyepiece is 6.25 into capital D is 25 divided by Fe plus D. What is the focal length of eyepiece? 6.25 plus 25. Yeah. What is 2 into 1.5? 3.
3, sir.
2 minus 1.5, 0.5 plus. What is 6.25 into 25? Approximately at least. Denominator will be 31.25. Approximately 25 into 6 is 150. No. So it should be approximately 156, right? Approximately I'm talking.
Yes, sir. Yes, sir.
Yeah. 0.5 can be taken as 1 by 2, right? 1 by 2. 3 by 0.5 is 6, right?
Yes, sir.
Plus additional term is there. Can you tell me approximately this goes with close to 5 times?
Yes, sir.
(156 by 31.25), close to 5, right?
Yes, sir.
So
Sir,
what should be
option
the
D, sir.
approximate focal length of the tube?
11 centimeter. Option D.
Option D, 11 centimeter. Any doubt, Ajay?
No, sir.
Yeah, you can see the calculation which I did here, but the calculation they have not simplified. This is just a substitution. You have to find the final value by substituting this. So this is the 11 centimeter. That is the length of the tube. Yeah. Shall we go for the next question?
Yes, sir.
Yeah. Yes. Look at this. What is the focal length of the objective and the eyepiece of a compound microscope they have given? F naught. What is the focal length of the objective lens? 2 centimeter, right?
Yes, sir.
What is the focal length of the eyepiece?
It's 3 centimeter.
Yeah, 3 centimeter. The distance between the objective and eyepiece. Distance between objective lens and eyepiece is given 15 centimeter, right? When the image is
Yes,
formed
sir.
at infinity. I told when the image is formed at infinity, length of the tube is V naught plus Fe, right?
Yes, sir.
Because when the image is formed at infinity, object should be placed at principal focus. So the object distance for the eyepiece should be the focal length. So it should be V naught plus Fe. That is the length of the image when it is at infinity. Yeah. So V naught plus Fe should be equated to for how much? 15
14
centimeters.
centimeter.
Yeah. Now, they are expecting you to find the distances in centimeter of what? Object and the image produced by the objective measure from the objective lens or respectively. They're expecting you to find the distances of the object and the distances of the image which are formed by the objective lens. This they are expecting you to simplify. Yeah. Now, focal length of eyepiece is given, right?
Yes, sir.
So, if you substitute this focal length of the eyepiece here, can't you get the value of V naught?
Yes, sir.
Yeah. After getting V naught, it is not that much difficult to find U naught, right?
Yes, sir.
Yeah. Yes. Let me simplify this for you. So they have given V naught plus Fe is equal to 15. V naught value we don't know. Focal length of the eyepiece is given as 3, which is equal to 15. So V naught is equal to 15 minus 3, that is 12. 12. V naught is 12. So either option A is correct because 12 is there. But in the option B and D, 12 is not there. So clearly you can delete this two option, isn't it?
Yes, sir.
Yeah. If you know V naught, can't you calculate U naught by using lens formula? Or you can remember this formula, V naught by U naught is V naught minus F naught by F naught. Magnification M is V naught minus F naught by F naught. Magnification is image distance by object distance, right?
Yes, sir.
So V naught by U naught equals to V naught minus F naught by F naught. If you not remember this formula, you have to simplify by using this. What is F naught? 2. V naught is how much? 12 minus 1 by U naught. So 1 by U naught equals to 1 by 12 minus 1 by 2. LCM will be 12, right?
Yes, sir.
This will be take the LCM and simplify. No.
So minus
Minus
Sir,
how much? 5, no?
yes, sir. Minus 5, sir. It will come 2.4, sir.
U naught. So what is U naught? 12 by minus 5. This
Yes, sir.
is
2.4.
minus 2.4 centimeter.
Yes,
So
sir.
this
Minus.
negative sign just tells that the object is measured opposite to the incident ray.
Yes, sir.
So object distance U naught should be equal to how much?
2.4 centimeter.
2.4 centimeter. So object distance U naught is 2.4. Image distance is 12. So which is the right option? Option A. If you don't remember this formula, then only you go with the general formula, right?
Yes, sir.
If you remember the formulas, you can use the direct int and you can simplify. Got it?
Yes, sir.
Yeah. Yes. Can you try this? It is a direct one. What they have given? Focal length of objective and eye lens. One is 1.2, the another one is 3. So what is the focal length of the objective lens? 1.2 centimeter. And what is the focal length of the eyepiece? How much?
Sir, 3 centimeter.
3 centimeter. Object is placed where?
1.25 centimeter away from
From the
objective.
objective lens. So U naught. Where the final image is formed? Where the final image is
Infinity,
formed?
sir. Infinity.
Yeah, magnifying power of the microscope they are using. Can you tell me it is a simple microscope or a compound microscope? Because in the question they have not told it is a simple microscope or it is a compound microscope.
So compound, sir.
Why it is compound, Ajay?
Sir, it has an objective and an eyepiece.
Very good. Since they have given the objective lens and the eyepiece, it must be a compound microscope. You know the magnifying power formula for the compound microscope when the image is formed at infinity, that is minus f naught divided by u naught minus f naught into d divided by fe. Have you remembered this?
Yes,
I
sir.
will just show the formula for you. This is compound microscope. See here, I told the magnification formula is this for you to remember. Minus V naught by U naught into D by Fe. Now I'm going to use this particular case. This second case. Or you can use this formula also. Minus V naught by U naught into D divided by Fe. D by Fe I have kept as it is. You have to substitute for V naught by U naught. V naught by U naught in the previous case also you can borrow. V naught minus F naught divided by F naught, right? That you can write it
Yes,
here
sir.
by using lens formula only. By using lens formula only. Actually, this is the standard formula. You know D is 25 centimeter. Focal length of eyepiece is given. Object distance U naught is given. But they have not given V naught, right?
Yes, sir.
To find V naught, you have to make use of this formula. 1 by F naught equals to 1 by V naught minus 1 by U naught. On substituting this, we can get the value for V naught. Then you can substitute here. This is the standard result. If you remember this direct formula, you can make use of this. So what I'm teaching, first I'm teaching the standard method. You know the standard formula for magnifying power of the compound microscope when the image is formed at infinity, that is minus V naught by U naught into D by Fe. In this, all parameter are given, but V naught is not given. To find V naught, you have to make use of this formula, which is called lens formula. You are familiar with the lens formula, right?
Yes, sir.
So in this lens formula, by substituting, you can get the value of V naught. Then you can substitute that V naught here to get the value of the magnifying power. This is one method. Or by substituting this V naught by U naught, you will get this. You'll get this. Yeah, you simplify. Check whether you will get 200 or not.
Yes, sir. 200, sir.
You got 200?
Yes, sir.
What about Dhanlakshmi?
Sir, sir,
You got
trying.
200?
No, sir.
Yeah, you do the calculation. Do it. Look at this. The magnifying power of what telescope is 8. Distance between the two lenses is 54 centimeter. You know telescope means image and object will be placed at infinity only. So what is given for the magnification? 8. Distance between the two lenses means length of the tube. That is 54 centimeter. They are asking you to find the focal length of the eyepiece. And also they are asking to find the focal length of the object lens. Yeah. In the case of a telescope, you know that length of the telescope is focal length of the object lens plus the focal length of the eyepiece. This L is given as 54. So 54 should be equal to F naught plus Fe, right?
Yes, sir.
So sum of this should be 54. See here 64 is there, 8 is there. So this is not possible because if I add these two, I will get 72. So similarly, this two is also not possible, gone. Correct, no?
Yes, sir.
So either option A is correct or option B is correct. As I said, in the case of a telescope, focal length of eyepiece is more or less. Okay. How do you define the magnification, Appa? Objective focal
Sir,
length divided by the focal length of the eyepiece.
eyepiece, sir.
This is given as 8. This is equal to f naught divided by fe. So f naught is equal to 8 times the fe, no?
Yes, sir.
So just have a look. I've explained already here. In the case of the telescope, I've written one term here. Look at this term. What is this? Focal length of objective
Sir, focal
lens
length
should
of
be more
objective
than.
lens. Yes, sir.
So clearly you can tell that. Clearly you can tell that focal length of object lens should be more than the focal length of eyepiece for telescope, no? So look at the option. First is telling that eyepiece. Focal length of eye lens. First one is eye lens. Second one is objective lens. First one is eye lens. So this is eye lens focal length, this is objective. This is eye lens focal length, this is objective focal length. Which is possible, either option A or option B. This is the focal length of object. This is the focal length of eyepiece. This is the focal length of object. This is the focal length of the eyepiece. Focal length of objective lens should be more, no?
Yes, sir.
So which is the right option?
Sir, A, sir.
Option A.
Yes,
You
sir.
got my trick, reverse calculation? Yes or
Yes,
no?
sir. Yes, sir.
So here you can substitute now. 54 equals to what is F naught? 8 times of Fe plus Fe. So 54 equals to 9 times of Fe. This implies Fe equals to 6 centimeter. So this implies 8 times of Fe, no? 8 times of 6.
Yes, sir.
So what is 8 times of 6? 48 centimeter. This is the focal length of the objective lens. So you will get the option A. Instead of solving all these things, you use the concept behind the telescope.
Yes, sir. Yes, sir.
Always in the telescope, focal length of the objective lens should be more. So clearly you can tell object option A is correct. Option B, C, D are ruled out. Yeah, in this page, 2 problems are there. Yeah. Very quite simple problem. Now, an object is subtending an angle 2 degree at eye when seen through the telescope, having objective and eyepiece focal length. What is the focal length of the objective lens? 60 centimeter.
60 centimeter.
What is the focal length of the eyepiece?
So 5 centimeter.
Yeah. Now they are expecting you to find the angle subtended by the image at the eyepiece. Eyepiece means beta. Eyepiece means beta. What is alpha? One angle they have given 2 degree. What is the magnifying power we have discussed? F naught by Fe, right? This M is also can be taken as angle subtended by the image to the angle subtended by the image for the object, that is beta by alpha. So beta by alpha is equal to F naught by Fe. Just substitute beta by 2 degree is equal to 60 by 5. Simplify this. What is 60 by 5?
Sir, 12, sir.
Yeah, cross multiply that 2. 12 into 2 degree.
24, sir.
It is 24 degree. So which is the right option?
C. Option C.
Yeah, option C. Yeah, try to solve this problem. Which instrument it is? What is the magnifying power?
So 30.
Yeah. What is the focal length of the eyepiece?
So 5
5
centimeters.
centimeters. Image is formed at least distance means capital D is how much? You have to remember that standard value. Least distance of distant vision means 25 centimeter.
25 centimeters.
Okay. Now the magnification produced by the objective lens they are expecting. M naught they are expecting, right?
Yes, sir.
Yeah. Now, you know what is the magnification for eyepiece? For eyepiece, it is given by 1 plus D divided by Fe when the image is formed at infinity. 1 plus D by Fe. This is for compound microscope. What is distance? 25. What about focal length of eyepiece?
So 5 centimeters.
5. So 25 by 5. 5. So 5 plus 1 will be 6. So the magnification for the eyepiece is 6 centimeter. 6. Can't you calculate what is the magnification of the objective lens by using this? You know that total magnification of the microscope is magnification of objective lens into magnification of eyepiece. So what is the magnifying power total? 30.
30,
What
sir.
about the magnification of objective? You have to find. What is
Yes,
the
sir.
magnification
6,
of
sir.
the eyepiece?
6.
6. So what is m naught?
So
30
5,
by
sir.
6, that is 5.
5, sir.
But have an option. There is both option A and option B with a plus 5 and minus 5. But you know that for the objective lens, this will be the object, right? Object will be at the left side, right?
Yes, sir.
Image will be formed at the right side. So V is positive, U is negative for objective lens. So if I take the ratio V by U, I should get negative, right?
Yes, sir.
Yeah. So magnification of the objective lens is always negative. So you have to go for plus 5 or minus 5.
So minus 5, sir. Option B.
So which is the right option?
B, sir.
Option B. So these are the different varieties of problems in optical instruments. In the next class, we'll start up with wave optics. That is the next topic of the ray optics. Okay. If you have any doubt related to ray optics, you can ask in the next session. Is it fine, Ajay?
Yes, sir.
Okay. I will stop at this stage. We'll continue in the next session, Appa. Thank you.
Thank you, sir.